Ask My Instructor 3.6.55. In this problem, we're going to find the equation of the line tangent to the graph at a given point. To start off, we need to find the derivative of the function. To do that, we need the quotient rule. Set up the quotient rule. And check your work. Next, we're going to find these two derivatives. The derivative of x to the 3 is 3x squared. To find this next derivative, we're going to use the chain rule combined with the power rule. Check your work. Bring down the 4. The new exponent is 3. And then we have to find the derivative of what's inside. The derivative of what's inside is just 2x. Put the 2x out in front, and this is what we get. Put these derivatives in our quotient rule. So, we have successfully used the quotient rule. Next, we're going to have to simplify the expression. To simplify, we are going to do three things. We're going to bring the 3x squared out in front of the factor it's being multiplied with. Then, after the subtraction, there's a good amount of multiplying to do there. We're going to multiply that. And lastly, we're going to use the power to a power rule. All right, so just to make a point here, don't expand any of those binomials. You've got x squared minus 3, you've got it to the 4th power. We're not going to do any expanding there, so just leave those factors alone. Okay, you ready? And when we do those three things, this is what we get. Okay, we're a little bit closer, but there's still some more work to do. Notice that x squared minus 3, quantity to the 3rd power, is a factor of both terms in the numerator and is a factor in the denominator. That gives us an opportunity to reduce. Let's divide the numerator and the denominator by that factor x squared minus 3 raised to the 3 power. So the exponent of 4 will go down to being an exponent of 1. And then in the numerator at the end, that is just going to cancel out. And then in the denominator, that exponent of 8 will become 5. So divide, and we get that. Check your work. All right, with each step we're a little bit closer. Now, we need to distribute the 3x squared. And combine like terms. And we are now ready to evaluate the derivative at the given point. When we evaluate the derivative at the given point, we're finding the slope of the line tangent to the graph at the given point. So let's do that now. Let's evaluate the derivative for x equals 1. Replace x with 1. In the numerator we get negative 14, and in the denominator we get negative 2 to the 5th power, which is negative 32. Reducing that, we get 7 over 16. So we found that the slope of the line tangent to the graph, we found that the slope is 7 over 16. If you have a point and you have a slope, then you can find the equation of the line. We're going to use what we call the point-slope form of the equation of a line. So for y naught, we're going to put 1 over 16. For x naught, we're going to put 1. For m, we're going to put 7 over 16. Are you ready to check your work? And that's the equation of the tangent line. To put the equation of the tangent line into slope-intercept form, we need to distribute the 7 over 16 and take the 1 over 16 from the left-hand side over to the right-hand side. Combine like terms and simplify. So we now have the equation of the line tangent to the graph at the point 1, 1 over 16. And we're all done. Again, it just takes a lot of careful work. Anytime you have the quotient rule, you have to be careful. And then we had a good amount of algebraic manipulations to do. But with the persistence and working carefully, we can get it done. Have a great day.